Let's talk about a little bit chaos to clarity. Building a data-centric IT, OT reference architecture. So some of this will become a little bit more apparent about the title, but it's just the title. So first and foremost, a little about me, because it's all about me, right? We're in an all about me, society now. So it's really, really important that it's about me. So my background. By training, I am an electrician and an engineer, electronic engineer. I actually started on valves because when I joined the Royal Navy in the UK, we had a lot of valves on ships and you used to have to repair them. So I've gone from valves to actual physical relays, from physical relays to programmable logic controllers, and from programmable logic controllers into software. So seen it all over those years. Worked with Mitsubishi, Rockwell, Emerson, GE Digital. Lived and worked in Japan for a while. Lived and worked in the US for a while. Based out of London now, working for Worldwide Technology as part of our manufacturing practice. Interesting role. I'm part of that manufacturing practice. I come from the operational technology side. That's where my background is. And working with my colleagues there, we look to help our manufacturing customers adopt the technology into the space. There's some challenges around that. There's a lot of consultancy. There's a lot of understanding on both sides of the house. So that's kind of what we do in trying to assist our customers in that space. So, moving on. Wrong button. There we go. So the chaos of OT. Right, especially when I'm with my IT brethren and they come in there and they look into that OT landscape and they go, man, it's chaos down there. How many, we've had that phrase, the wild, wild west of OT, right? That shadow IT that sits in an organization. All of those phrases, right? As if these guys don't know what they're doing. These trained engineers that have got all the letters under their names in their particular field, don't know what they're doing, and they've just, cobbled all this stuff together for no reason apart from making it difficult for everybody to understand. So, well, why is it there? Big thing, touched on this morning, and the short piece we had this morning, legacy hardware and systems. At the root of this is lifecycle management. Right, life cycle management in the IT space, 3 to 5 years. OT space, 15, 20, 25 years, 30 years. Interestingly, I was at a customer last week. We were doing a workshop, and they were going through the devices that were all on their, their systems, and they were trying to trace the network right down to the lowest level, device level, and then they would pick out a particular device, and then they go, "Hey, that's obsolete." And I was in the room with it and I'm going, damn, I introduced that when it was new. It was the SLC 504, the first one to have an Ethernet port on the front, and I was there. I helped introduce that product. So yeah, it is really interesting. But there's a lot of that. It's there, right? We have to deal with it. It's not gonna. It's been there for a long time, so it's settled, right? It's not going to move there. So it's a challenge. But it needs to be, treated in the right way. It's not rip and replace. Just isn't going to happen, right? So it hasn't happened in the last 20 years. So there's no great idea that's going to suggest that you're going to come in and just change it out straight away like that. Lack of connectivity. We've got isolated, pockets of control systems that are working in there. Well, why did they do that? Well, a couple of reasons. One is they never had to share the data with anybody, because it needed to be just supporting that local control, those local process or that, local machines. And that was its purpose. It was designed that way, right? It didn't have any need to connect and provide data or, provide any services to anywhere in the organization. The other reason is, didn't the security guys tell them to disconnect some of this stuff? Didn't they say that was the best way to actually protect it, disconnect it, right? So some of them did. They went to physical separation, like physical, literal air gaps, real air gaps, right? So there was no connectivity in that space. So again, it's normal, right? Some of it's been done by design, some has just been because connectivity didn't exist when these first systems went in there. Again, no surprise, it's normal. Data silos. So I think they've been collecting data in the industrial automation space probably longer than they've been collecting data in the IT space. Because, you know, utility companies, oil and gas companies, particularly in pharmaceuticals, had to capture that data and keep it for decades, right, to show to regulatory bodies in the event that something happened, that they had the traceability in there. So they had these things called historians, right, real-time databases that are different to SQL databases. And they still have them, and they still have pockets of these lying around, whether it is hooked up to a SCADA, whether it's hooked up to an HMI, whether it's hooked up to a business system. They exist in that, you know, in that operation. So there are these little buckets of data, sometimes very big buckets of data, because it could have 10, 15 years worth of data, right? Archiving, not really a thing that was done. They just keep on pouring it in. You just keep on pouring it into that data bucket is common. So you've got data silos. Vulnerabilities. Well, it goes with the first point here, right? If you don't change it and you don't update it, and there's new attacks and things like that coming out, then you're going to have vulnerabilities, right? So it is a challenge. Depends on the risk that organisations are willing to, you know, take on as part of that, and it will mean change. It will need updating of there. But again, shouldn't be surprised. So, you know, your InfoSec guys coming in there and looking and go, oh, there's loads of vulnerabilities. Hey, that's really old. That's a Windows NT machine. That's another one I remember going in there. But again, that's normal. Cost of change, all of these different things are the reasons why it's still there. So it's really important to understand why it's still there. Just not come in there and say, hey, you're stupid, you're running this old version. Why don't I just run an update? No, don't do an update. It will shut our production down and we'll start losing money really, really quickly. Documentation gaps. If only they had the documentation, it would make life so much easier, right? So traditionally, when they buy pieces of equipment that they have control and automation on it. They don't specify the control and automation typically of what it's going to do and how it connects and the stuff. It's designed to create a packaging outcome or a process outcome. It's not inherently about what's, you know, built into that system to be able to deliver against that. So therefore that tends to be left with the OEM or left with the system integrator. And unless they've specified that as part of the outcome in the package that documentation is included, it won't be there, right? But again, that's normal life for these guys, right? Because these guys are electrical engineers that are used to fault finding, used to getting their hands dirty, getting screwdrivers out and go fixing stuff and, you know, without manuals, right? So again, very, very common that this exists in there. It would make it easier, but you can't assume that it's going to be there. And again, not be surprised that it's not there. Knowledge gaps. I think that's everywhere, right? The skills gap is not unique to this particular space, but it is a space that not only do they have their inherent technology they're using in that environment, but they've got new technologies, you know, penetrating into their space. There's a lot to be learned. There's a lot to understand. And these guys on the floor are really, really busy, right? Fixing things when they go down and keeping the products being, you know, pushed out the door. So if you go to site and you're meeting with one of the control systems engineers or something like that, they got their bleeper on, they got their, and they'll suddenly go, sorry, meeting ended, I've got to go, right? And I've got to go fix a bit of plant because they're shouting at me, right? So it's really difficult for them to create the time to actually fill those gaps. Because it needs to be recognized that there's an educational process that we need to work against. So those are just kind of some of the things that why, you know, you look at it from one particular purview and you think it's chaos down there. It's not. There's genuine reasons why it's all there. And I could talk forever about going through the history of isolated singular PLCs to network PLCs, to then networked with SCADA controllers on there and HMIs and how they've built up the stack So in the same way as the IT stack is collapsing into the OT environment, the OT stack over those same years is moved up. And what we're seeing now is that overlap, that convergence at the level 2 and 3 of the Purdue model. And I'll talk about the wonderful Purdue model in a minute as part of this presentation. But that's what we kind of see in this space. Right on cue. Let's talk about the Purdue model. Right. Maybe a little bit controversial in some respects, but it's designed to, highlight that there is no singular answer to all of these things. There are different approaches. There are recommended best practices, but there is no singular standard that's going to solve all the problems. That tends to be really difficult for engineers to grasp. They want a standard. They need to read it and follow it to the letter. And that really, really makes it more complicated because they were never actually designed for what they're now being purposed for. So, description there, Purdue University, 1992, whatever it was there, designed to do with the interaction of the systems. That's what it was designed to do, so that you communicated up the stack. So from your devices to your controller, your PLC to your HMI or your SCADA there. Going up to the next level, we're going to your MES, going at the next level to your enterprise, and along came the cloud, so they just bolted that one on the top because that's where it's set. All designed to exchange data in there and going up and down, right? Gave it a kind of a framework to understand it. It was logical, so we understood it, and it made sense that if we then bound our systems like that, then we're following a reference. And that's kind of what it was designed to do, and make sense to people. And then be able to apply different technologies at different levels. As I said, divides it into those 6 things. Can be used for data flows initially, but more and more so now we're seeing it from security. So the security guys have seen it and said, hey, there's levels there. Why don't we just chuck things in the middle of these levels and box them all off, and then now we've got a way of managing our security around our Purdue model. Yeah, logically that makes sense, right? You can do that, but it may have some challenges in how you approach that. So, what does Gartner have to say, right? Gartner, everybody has a different view, whether they're the leaders and thought leaders, whether they're just commenting on the industry, or whether they know anything at all about whatever. It doesn't matter which side of the the spectrum you're on, but they do create a lot of good content. They are thought-provoking around some particular topics, and it's really interesting to take a look at this particular subject here. In 2018. They kind of said that the Purdue model was great for monitoring and ICS security. Again, similar to what I said, it's like, yeah, it makes sense. We've got a security problem now. We want to structure. How are we going to segment? How are we going to protect and isolate these particular zones, between the IT level and the OT level and then further out? It makes sense for Purdue fits that narrative. You can model that into that security thing. That's good. And, again, they were talking about segmentation, and there's many different ways about segmentation that are happening, whether it's physical separation using firewalls, whether it's now moving to software segmentation and how that can be done in a network. All of those different things are valuable and be able to secure in the network, and it does provide that framework. But in last year's report, July 2023, there was a change. And they came out and said, it's outmoded architecture. It is now not the best way of approaching your IT, OT combined infrastructure for a manufacturer. And I showed the Nokia phone there. In its day, it was great and fantastic and fit for purpose. And I think we actually had that model at some point or whatever. But like everything, time goes on, we change, we age, we become less useful, we're less appropriate for the changes in the market. Now, I'm not saying that the Purdue model is completely irrelevant, because it's not. It's still a valuable angle to look at your IT/OT systems. However, it's not necessarily going to be the best model to follow for all of your use cases. So it shouldn't be the default of actually. You consider it, you look to apply it, and if it's relevant, you can use it. But you've got to think it through and adopt what's right for you as an organization. So this is another thing about going back to standards, right? And this is what engineers should embrace is, in theory, it just all works, right? It just all hooks together and you can use it, and as a standard, I'm going to put it in there, it's plug and play, and I turn it on and it's fantastic, right? Never quite works that way, right? It requires a lot more effort. And it's about applying, a bit of theory with a bit of practical, right? So be practical about it in how you adopt it and what you're looking at. So, it's in terms of security and like data exchange, and we're seeing that a lot with some of the, depending on where our customers are coming from, they may be driven right now by, security. And security will suggest that you lock everything down and you only let things pass, through it, what you see today, right? And you then create potential barriers for the future. Well, what does that mean? It's not that you can't change it. It means there's going to be a cost of change. And the biggest thing that's happening with technology that's hitting into the OT space is the cost of change, time to value, and it's down to system integration. That's why getting those data silos hooked up is because you need a system integrator to access an API or introduce a new driver or put another stack on. It's just a lot of work and effort. It's not about can it be done. Nearly all the time it's yes, it can be done, but the question is who are you going to need to do it, how long is it going to take to do it, and ultimately if it takes longer, it's going to cost more. So it's about thinking a bit more broadly, envisioning what the future state might look at it and how you want it to be, and consider that when you're applying your security controls. Not just applying your security controls for how it is right now, because I can guarantee if you do that, you'll be secure, but then you'll be changing it really, really soon. Because someone's going to come along and say, hey, open up that port, do that thing. And you're just going to recycle, go back to the same place. So think for the future, and then as you move forward, design that security elements in alongside your data as well. And don't let the security doom mongers dominate the conversations with risk. Business valuable is far more tangible and realised more often than risk is. Fact. So the chase for business value should be overriding on dealing with the risk assessment. Now, if you're driven by industry bodies or insurance companies right now and putting it into their contracts and how you must have an appropriate level of security down there, it doesn't say what is the appropriate level of security. It doesn't dictate a standard. It doesn't say that you must go and choose this particular one. It just said you must be security aware and you should be applying some sort of security measures to your system. But as we drive towards value, then the value that's going to be, that the organisations can benefit will outweigh the risk. So it's a business decision, right? And it needs to be taken in that context. Because if you pivot too far to the security side, there's a danger that you're actually extending your time to value, and therefore you're not going to be able to benefit from some of the new technologies, particularly around AI that needs data, right? AI does nothing without data, right? So you could be hindering how much your progress is going to be in those particular areas. And then we move on to, lean on to this data-centric architecture. So where data is at the center. I did a presentation last year at this show was, it was about data pipelines and where, the data is the lifeblood of an organization. We've heard the phrases, data is the new gold, data is the new oil, and it really, really is. The point being is, it's extremely valuable. extremely valuable for so many use cases, so many, that it's really, really important that you manage that data to your best effect. You have access to the data when you want it, and it comes in a format that you can understand so that you can then turn that data into information, to knowledge, to business value. You know, all of these things that we've heard many times before, but it really does need organizations to look at data in a different light, look at their OT systems in a different way. It requires a data-centric mindset. It's all about the data. That's what I'm trying to get out. That's what I'm trying to extract from that machine, from that system, from those quality labs, from their R&D labs, all of those different aspects of the business. You're trying to extract the data in a reliable and secure way that can then democratize that across your organization for all of the business analysts, all of the data scientists can then use that to focus on the value to your organization. Move away from application centricity. Really, really important. Vendor lock-in. So many, you know, again, there was only one type of solution that has been available in this industry for a long time, and that was a vendor solution, a vendor-driven, a vendor-supported, and a vendor technology roadmap-led solution. It's good in certain circumstances, and it's not, again, not the wrong thing to do, but you are not in control of your destiny. It's down in the hands of the vendor that you choose. Now, I won't mention some vendors out there have made recent decisions about particular technologies that are no longer going to be offered. Big companies. How does the organizations that have adopted a vendor-led solution going to get out of that, right? How can they deal with that? So moving away from an application centricity, more towards data, usually moving towards a more component-based architecture, so you can chop and change, you can move things in and out of the stack, depending on what's best, what's available, what's, you know, specifically needed for a particular use case, you can put those in there. So again, different way of thinking. The benefits, it simplifies security because you're dealing with security at, you know, at the component level, not at this holistic level, trying to lock everything in, break it all down, you design it in. You've got agility to be able to scale. You've got agility to change as you bring on a new, if you want to bring on new technology, new components. You can get faster insights, right? So if the data's available, you can give it to the people that are going to come up with those insights. If they can go and get it, then they can actually start working on it now. How many projects I've been involved with is the business analyst says, hey, I want the temperature values, I want the pressure values, I want this, and this from these machines. Can you get it for me? Yeah, but it's going to take you 6 months to get that data. And then they go, well, can't I even get a CSV file or something like that? Well, yeah, you'll get that quicker, but you can't operationalize that. So you might prove your point, but you're still no closer to being able to getting closer to that, you know, ongoing, recurring business value out of it. So it's really important to be able to do that. And, you know, you don't want any sort of costly middleware in there. Again, it's moving around and you know, moving away from too many dependencies around any particular component or any particular application. Now, recognizing what I've said before is, you know, you've got a lot of legacy systems, and then when we're talking to customers, we'll say, we'll meet you where you are, right? This is, you know, if you have them, you've invested in them, there's skilled people there, there's a lot of data in there, there's a lot of value in there, but it's working around that, and then looking to a future that says those are no longer going to be as important as they maybe were in the past. So, I know the man who first coined this is going to be on this stand later on today, Walker Reynolds. And, you know, he talks about, you know, a unified namespace project developed in 2005. And then it's data-centric and it's accessible and dependable. Now, I'm not as clever as he is, but I think I was just calling it this morning. I think around about 2012, 2013, I did an ignition project for London Underground, and it was asset condition monitoring of lifts, escalators, computer equipment rooms, all of those types of things across their network. And the really important thing is I took out of that is actually developing a naming convention. So I adopted a naming convention to it. And I actually, in that instance, because it was asset management, I went to an asset management naming convention because they existed, right, at that time. It was Mimosa. They basically took some of the principles of it and adopted it into an industrial use case. So it gave the kind of, from site to level to, a zone to device, and then from device down to each individual parameter. So, and then it was done in a kind of understandable format, not some hieroglyphics or special numbers. It made sense. But what did that make a difference was? Well, it meant that anybody who was going to encounter that data for the first time would get it, would immediately be able to go there and I say, that's the temp value from motor 1 that's on line 3 as part of packaging line in that building on that plant. Now, it sounds obvious, right? But often you go into a case, there'll be a value that says PV 186234. That's the data point there, but you've got no documentation, the skills gap, finding that data is extremely difficult. So it's laying the foundation for a much beneficial world. It's in real time, it's got historical data. It's a fundamental shift towards a data center architecture. It's not the answer, it's not the solution, it's a concept. Again, it goes back to having a data-centric view and how you're going to work on it and how you're going to lay the path and foundation for success in the future as you build your systems. So just in conclusion, data now, in my opinion, is the cornerstone for manufacturers to be successful. If you don't have it, it's like building, a big high rise on some really creaky foundations. It's a foundational element. When we engage with customers, we actually, put it into 4 different foundational elements. One is the compute infrastructure, the things that you're going to run, applications, we're going to run your network, whatever type of network that is, wireless, conventional, Ethernet, TCP IP. Security is a foundational element. It needs to be there. And the last one is data. All foundational elements that need to be strengthened to be able to support the future use cases, to be able to deliver value as a manufacturer. Data is powering the AI revolution. They can't do anything without data. So if manufacturers want to embrace AI around inspection of improvement of quality, in production, predictive maintenance, all of those different things, they're going to need to build models, and they're going to need to feed those models with data. So data needs to be started collecting now, if it hasn't already. It needs to be normalized, contextualized, cleaned up, because a lot of data will be of poor quality that exists out there. And then that will set the foundations for anybody to move to that, embrace the AI revolution, and then outperform their competition. And this race towards digital excellence that we're all going through across all different areas, data is a compass that can steer towards innovation. Imagine if you can collect all your data from all your operations, and it can be readily available to anybody in your organization, and then they can tap into it, and they can inspect it, they can compare it. They're going to come up with a vision of what good looks like, what they can do to change, and how they can move on and advance business value within their business and move forward and outperform their competition. So that's all I have for today. Thank you. I represent Worldwide Technology, and Litmus is a key partner of ours in this manufacturing data space. And I welcome any questions you might have.
You touched on ES briefly, and you mentioned it was a concept. And you said the concept is more about the naming of the data structure and then the distribution of that. How you would do it is kind of not as important.
I think they're both important, right? So myself, from my own personal opinion, naming is more important than how it's distributed, right? Because you can deliver a message in many different ways, right? But if you don't construct the message in the right way, then it makes it that's meaningful to the person or people or organizations that are going to receive that. It complicates the time because it needs to be processed to understand at the other end, right? So I think that is probably what I'd say is the primary importance. Come up with a naming convention, adopt it, enforce it, instruct your OEMs when they're delivering equipment to use it, because then you can get to this like state of digital readiness of your equipment, etc., etc. How you deliver it, there are many options, right? So whether that's through an OPC-UA type structure, whether it's through an MQTT broker, whether that's other methodologies, some of the the message brokers from the IT stack, Kinesis or Kafka or NATS or other type of things. Effectively, they're different ways of transporting it. But so I would say first and foremost is having the structure, and then separately how you're going to deliver it and how you're going to democratize it.
Good. So I would agree with the naming part is the most important. So part two of the question is, as UNS becomes more widely known, accepted, I think the practice of the naming standards and conventions in a lot of places has already happened plant to plant to plant. However, the reconciliation of those naming standards is now you share that data outside the plant across the enterprise is where the fight begins. Have you seen that kind of a dilemma where they have naming conventions but they're using different ones in the same company at different plants, or even in the same plant in different cells in different areas? So like the machining line is using this naming convention and the assembly line is using that naming convention. And how do you reconcile that as a consultant?
So I agree that there are different, no naming convention or differing naming conventions.
No, or different.
And there is a naming convention that exists in most organizations that are going to be in the IT layer. It's going to be on their ERP or their asset management is going to have one, right? And at some point, these are going to, the data streams are going to collide because they need each other, right, to be able to operate it. So I think that the challenge there is obviously it's easy to say, well, you can aim to have a singular naming convention, right? But that will actually get into the biggest challenge in the transformation is being able to the people, the organizational structure is really, really where the challenge is. It's not that they don't, it's getting them to agree. I think when you analyze it, there's not a lot of difference. It's just how it's similar, yeah. It's how it's been implemented. But I think right now it's about engaging in that conversation. Surfacing that conversation as really, really important because it's been ignored for so long, and then they just go off and do their own thing, which is just propagating the failings of the past. To be able to build up again, because you're just going to have ETL right somewhere in the stack.
Yes.
You want to minimize it, but you can live with it, right? It can be lived with, but what you don't want is just too much of it that it becomes preventative from utilizing the data.
One strategy we used way back in my past was to get the procurement team involved when you're sourcing the equipment on the shop floor.
Yeah.
Because they won't write the naming standards in the contract.
I totally agree with that. I instructed a customer of ours probably about a year ago, and I said it must be in your documentation. It must be that when you present data, we want you to present data, and we want to present data in this way, and I want it in this structure, and I want it in these values and these formats and all those things. It goes into the standards, and when we engaged in that particular project, when we engaged the system integrator, it wasn't actually a problem. They're actually doing it already, but they're not being told what to do, so therefore they do whatever they think.
Yes. Yes. Or I've seen it where they don't do it, but then if you're trying to validate that the data coming out of your machine is correct, that's pretty hard.
Yes, exactly. Yeah. Thank you.
Over to you, Dave.
Thank you, David. Thank you, Mark. One of the questions, you mentioned data governance in one of your slides, and I think that's a very important part that people are just starting to talk about right now. And I think this aligns with what you were talking about with the naming convention. And why didn't we do that with OPCBA? Why didn't we do that with OPCUA? That's something has been done. I think one of the things is that we now have the ability to centralize that naming convention that you're talking about, or that data structure in a place. But I was wondering if you could just talk to that a little bit more about data.
Yeah, so again, if I recall back to that example I was saying about the London Underground particular project, we put in a naming convention, but it was put in by the developers of the system and we insisted on it. It wasn't necessarily enforced. And we did it using OPCUA, right? There was nothing preventing us from actually adopting a naming convention in that space and be able to use it. But it makes it a lot more difficult to scale it, and it makes it a lot more difficult to maintain it and ensure that multiple developers are following the same convention, and it kind of gets out hand. So I think that having tools to be able to enforce it are critical to its success, right? So being able to ensure that all tags are, named in a certain way, have the same structure, and there is no option, there is no wild card, right? But if the data structure is set out in the right way, it will give flexibility. It allows for flexibility, but it can't be set up that you're allowed to wild card it out, right? It can be able to do this because eventually all the wild cards were used all of the time, and then the actual data structure gets destroyed or is reduced in its value. So being able to enforce it I think is critical to make sure that's, you can enforce it by telling them to ensure it's in the specification, right? But someone's got to check it, right? Now, you either check that as part of your acceptance testing, which you can do, right? Because you've got to acceptance test the stuff anyway, so why don't you check the data at the same time? But that doesn't do it when something gets changed, right? Or something gets added on, or extended, or whatever it is. That's not necessarily what they're going to be looking at. So having tools to be able to enforce that, easily manage that, and then scale that, I think is going to be is really valuable.